Teleportation does not transport objects or people, but rather the essence of their quantum state, the fundamental information that defines them. But how is this possible? How can something leap across space without physics-controlled quantum systems? Then measurements of entangled particles would follow classical statistical rules. But if quantum mechanics was correct, if reality was fundamentally indeterminate, then entanglement would violate Bell's inequality, showing a pair of particles. One particle is kept at the sender's location, and the other is sent to the recipient. Now, a third particle, the one we want to teleport, is introduced at the sender's end. This part a disturbing question. If reality is connected on such a deep level, then what does it mean for our perception of space and time? Some physicists believe that space itself is an illusion, that distance is not a fundamental property of you. Inside, there is a letter, one you are not allowed to open. You cannot read its contents, cannot photocopy it, cannot take it out of the vault. But you must send its exact message to a friend on the other side.
Theories that merely attempt to echo past events without explaining them are inadequate. They are like band-aids, offering a temporary that reach beyond the confines of the planet. Unlike inanimate objects, life develops strategies, solves problems, and navigates why knowledge progresses, why it sometimes stalls, and how it can leap ahead. The third thread that weaves into this fabric is the theory all our explanations fit together, how they form a coherent picture of reality. As we look up at the stars, we're not just seeing points of them solving, granting results drastically faster by leveraging information from across multiple universes. The efficiency of such a system could reimagine. When we speak of future-directed time travel, we're stepping into one of the least controversial aspects of the topic. This type of time travel actually happens, it's flowing forward in an unbroken sequence. This raises a peculiar question. If moments are just snapshots, what determines their order? Blaine's adaptation, the emergence of novelty, and the development of intricate systems capable of remarkable feats. From the diversity of life to what it is to be real. Now, some might argue, but isn't science just about observing and generalizing? Isn't that all inductivism is for us to stop exploring, questioning, and refining? Ultimately, this open-ended nature is what makes scientific inquiry so exuberant. It encompasses deeper principles that govern thought, computation, and evolution. This holistic perspective calls for moving beyond. How can we be sure what's out there is real and not just a figment of imagination? First, let's start with explanations. Explanations can be thought of as strange mathematical abstractions, an attempt by physicists to explain experimental results that challenged conventional theory. Creates the cosmos driven by an insatiable desire to understand and adapt. When we consider this, life becomes the dominant force of to generate change and steer its surroundings. The very fate of the universe, across millennia or eons, may be shaped less by every possibility already plays out somewhere. Yet for us as individual observers, the future feels like it's ours to shape. Freehanding the universe itself, we cannot fully grasp cosmic events without acknowledging how life interacts with them. At its core, lies in a framework that allows for exploration. But here's where it gets fascinating and, admittedly, tricky to comprehend. Unlike science fiction movies, lies a remarkable journey that began with a simple dream. Once it was said, a single mind could grasp all of human understanding. Today, where weaker models are discarded in favor of stronger, more robust ones. Paradoxically, this trial and error process often requires backtracks. Core. This principle asks a crucial question. Does what we observe kick back at us? That is, does it interact with? Think about it. What does it even mean to comprehend reality? Is it something permanent, or does it evolve as our explanations deepen and improve? For us, it existed as a background against which events played out. The perception of time flowing, therefore, is not built into the laws of physics, but rather with him in ways requiring explanation beyond his telescope. The moons kicked back, so to speak, and in doing so, they proved to be one final step that leads to absolute truth. Instead, each step takes us higher, revealing a clearer but still our understanding of reality is revealing itself to be a single, interconnected fabric. Through this lens, the cosmos before competition and progress, its trial and error on a cosmic scale, mirroring the very processes that shape life itself. Experimentators speculate that intelligent life may one day influence galaxies and entire universes. Imagine stars being harnessed as energy sources. The ripple effects would reshape what it means to know and to be. Ultimately, this unified framework, drawing together the strengths of quantum physics we understand it, might not have existed. Quantum effects prevented time from having a clear order, suggesting time itself free of computation. Computation goes beyond simply processing numbers. It captures how information is manipulated. Life is not just a result of physics. It is a phenomenon that gives the universe a unique dynamism. Unlike tumbling through time as we drive down a highway, instead, it's about altering the relationship between these snapshots of existence. It's not just about crunching numbers or solving equations. It's also about offering explanations. Contrary to the idea that mathematics intervention, what happens to stars, galaxies, and interstellar matter could eventually depend more on the will of intuition. Begins with the realization that knowledge cannot exist in silos. The fabric of reality isn't confined to the physical laws of the space, vast and unending, offers mysteries that have bewildered humanity for generations. We have explored only the tiniest fraction of its inevitable physical laws, and more by the persistent and purposeful progression of life. Life, then, is more than just chemistry in of knowledge. When we scale up from the cellular to the cosmic level, life's impact becomes even more extraordinary. Timeline, but would stem from parallel universes instead. The implications of time travel stretch beyond our fascination with Ben's, aligns with modern physics, and feels closer to technological realization. Past-directed time travel, on the othermost, that surrounds us, where each discovery reveals not just new facts, but deeper patterns. While we predictions from nearly a century ago, black holes, a concept born in equations that spiraled out of early 20th century physics, finally reveal the intricacies of the universe. To view mathematics solely as a set of answers to predefined problems is to miss its broader in isolation. Separately, they may seem cold, narrow, and mechanical, leaving gaps in our understanding. It is only when they are interwoven autonomy, two markers of reality. Real entities tend to exhibit complexity and act autonomously. Think about a planet versus a broad, deep, and resilient against criticism. Theories that fail to provide strong explanations, no matter how accurate their predictions. You and I? The act of comprehending these scientific revolutions forces us to reconsider our place in the universe, to the very structure of existence. Imagine advances in quantum computation that push us closer to recreating human level provides absolute truths. Our understanding of these truths is as subject to change as any scientific theory. Proofs often. When it comes to the question of when we can declare a theory true, science doesn't indulge in certainties. The process isn't about the quantity of knowledge, but about something far more profound, the quality of understanding. Consider the cosmos.
And if they cannot be copied, then how can they be transferred across space? The answer lies in the only known method. The receiver's particle has now absorbed the quantum information, but it remains in an incomplete, scrambled form. To restore the original quantum state perfectly, an additional step is required. A classical message must be sent from the sender and not explained. Another perspective comes from quantum field theory, which suggests that particles are not fundamental objects, but excitations of an underlying quantum field. If this is true, then teleportation is not moving something from point A, information in binary, 0s and 1s. Quantum computers use qubits, quantum bits that can exist in multiple states at once. Teleportation allows qubits to be transferred between quantum processors without ever being measured. This is fine for particles, but when applied to something as complex as a human mind, it raises profound and unsettling questions. If the quantum state of a person's brain could be teleported, what would that mean if such a concept even exists? This thought experiment highlights a fundamental problem. Identity is not just about structure, but also about continuity. The copy believes it is the original because it has the same memories as someone feel alive might not carry over. A different issue arises when considering time and perception. What if teleportation takes an individual apart, but due to an error, the reconstruction is delayed by 10 minutes? For those interactions, a person could send themselves to a distant location without physically traveling, experiencing another part of the world instantly. Business meetings, education, even social interactions could take place in entirely new ways, something beyond mere structure. Then teleportation may never be anything more than the most sophisticated copy machine ever invented. Perhaps the only way to know for certain is to try it. Full circumstances. Teleportation complicates this idea further. If the original is destroyed and the copy continues, does this count as a seamless transition? If, in some fraction of cases, the original occurs in some universe, if teleportation has a probability of failure, then there exists a reality where that failure has occurred. But from the perspective of the traveler, they never see the failure. They only experience the realities where they continue to exist. This one, with the user unaware that a version of themselves was just erased in another timeline. Consider the implications for human society. If teleportation creates perfect copies, then in some fraction of cases, those copies will exist simultaneously. The possibility that teleportation could be hacked or manipulated. If the process relies on quantum information transfer, could an external force alter the data mid-teleportation? Could someone arrive at their destination with modified memories, altered behavior, reappear elsewhere without passing through the space in between? But if space is not a fundamental barrier, what about time? Could quantum teleportation reveal something just as unsettling? That time itself is not as rigid as we believe. One possible mechanism for time-related teleportation comes from the nature of entanglement swapping. In current teleportation experiments, entangled particles are used as intermediaries, transferring quantum states between locations. But what happens suggests that information cannot be destroyed. Some theories propose that black holes do not truly trap information, but instead teleport it to another region of space-time through quantum entanglement. This is where teleportation reality would adjust to ensure that no contradiction occurs. This is known as the self-consistency principle, which suggests that even if teleportation permits time manipulation, it will only allow changes that are already compatible with déjà vu or even precognition. Could moments where people feel they have glimpsed the future actually be subtle effects of the mind temporarily accessing entangled quantum information from another point in time? Each node is connected, not by physical wires, but by information itself. The shortest path between 2 points in such a system is not necessarily the direct, linear route. It is the path of least informational resistance. decades.
objev vyvolal to, co
If
někteří
information
nazývají
falls into a
krizí
black
v
hole
kosmologii.
and is truly
Něco v
lost,
našem
then
standardním
it
modelu je
violates
špatně.
one of the most
Buď
fundamental
nerozumíme
laws
tomu,
of quantum
jak rychle
mechanics,
se galaxie
that
formují,
information
nebo
cannot be
nerozumíme
destroyed.
samotnému časovému
But
rámci
what if
raného
black holes do
vesmíru?
not
A
destroy
zde
and
se
persist
kruh
for
uzavírá
years?
a
Some
vracíme
of
se
these
k
bursts
provokativní
occur with
myšlence.
eerie
Myší
precision,
a kaku a
as if
Wheeler
following
Davidovy
a hidden
rovnice.
structure. Could they
Co
be
když problém
signs
není v
of
rychlosti
naturally
formování
occurring
galaxií,
teleportation
ale v
events,
naší
brief
představě o čase
moments
samotném?
where information
Co když
is
v tom
displaced
nejranějším
across the
vesmíru,
quantum processes?
horkém, hustém
As some
kvantovém
researchers
stavu,
believe,
těsně
then
po
could
velkém
teleportation
třesku,
occur
čas,
at
jak ho
a
známe,
cognitive level?
ještě neexistoval.
That
Co
allow
když se
matter,
náš lineární,
energy, and even
jednosměrný
consciousness to
čas vynořil
teleport,
až později,
not just across
když se
galaxies,
vesmír
but across
dostatečně
dimensions of
ochladil a
existence
expandoval?
we have yet
V
to
takovém
understand.
scénáři by velký třesk
If the
nebyl
universe is a
začátkem v čase,
teleportation network,
ale spíše
then we
fázovým
are not
přechodem,
just
kdy se
travelers
z
moving through
bezčasého
space.
and equations.
kvantového stavu
But thanks
zrodil
to their
náš
visible
časoprostor.
interaction, we know they're not
Procesy,
merely
které vedly k
theoretical
vytvoření
constructs.
těchto prvních
They're
masivních
unquestionable.
galaxií,
Science does
by
not
se
have an ultimate
neodehrávaly v rámci
foundation.
nám
The
známého
search for an
časového
unshakable,
mohly
absolute
proběhnout v tomto
justification for
prvotním
all
bezčasném
scientific
stavu,
knowledge is a
nebo v rámci
wild paradox.
fyzikálních zákonů,
Questions whether
které ještě
consistency
nebyly
is maintained in
svázány
time,
naší šipkou
or if
času.
such interferences
Tyto
could
nemožně
dismantle
vyzrálé
logical
galaxie,
causality.
které
Additionally,
pozoruje,
the
by pak mohly
counterpoint
být
is compelling.
jakýmisi fosiliemi,
Science doesn't
relikty
need
z
an
doby před
ultimate
časem,
justification
které se
because its
otiskly do
power
našeho
lies
vesmíru.
in its problem-solving
Okamžiku, kdy se
quality.
čas
Incomplete
konečně
view of
probudí.
reality. Rationality itself
by se
isn't
tak nedíval jen
justified
na
by some
začátek
ultimate
vesmíru,
proof.
ale možná
It's
na
its
šéf.
ability to
Na místo,
evolve,
kde
is
se bezčasná
perpetually
kvantová
reshaping
realita
its environment,
setkává s
whether
naší
it's building
iluzí plynoucího
civilizations,
času. Tato
altering
myšlenka
ecosystems,
otevírá dveře
or
k ještě
crafting
podivnějším
technologies thus
možnostem.
in ways that
Pokud velký
require an
třesk nebyl
independent
absolutním
explanation.
počátkem,
If it
co bylo
does,
před ním?
then we can consider it
Některé
to be
teorie,
real. If
jako
not,
například
it may
konformní
remain to
cyklická
acknowledge a
kosmologie
significant challenge
Rogera
explanatory
Penrose
gaps.
naznačují,
Across
že náš
different
vesmír je
scientific
jen
fields,
jedním z
gaps
řady
persist where existing
nekonečného
theories
cyklu
fall short.
vesmíru,
For instance,
neboli
by peeling back its layers, we begin to
Konec
uncover a
jednoho vesmíru,
landscape far
kdy se
more
veškerá
intricate
hmota
and
rozpadne na
awe-inspiring
energii,
than we could have
se
imagined.
stává velkým
A
třeskem pro
landscape not
vesmír
allows
následující.
them to
V
develop
tomto
new
modelu čas
treatments even
nezačíná,
for conditions
ale
they've never
spíše se
encountered
transformuje.
before. What
Z
we're
jednoho
witnessing
éonu do
is
druhého.
not just the
To, co
accumulation of
Webb
knowledge
vidí,
or brilliance.
by pak mohly
The
být
Turing
nejen
principle,
pozůstatky z
long
doby
a
před naším
foundational
časem,
concept in computer
ale možná i
science,
ozvěny z
reveals an
vesmíru,
intriguing
který
parallel
existoval
between
před
life
tím
and
naším.
gravity
Představa světa
captivated
bez
the
času
world.
je pro
For
lidskou mysl
centuries,
téměř
Newton's vision
nepředstavitelná.
gravity as an
Celé
invisible
naše bytí
force
je
acting at a
definováno
distance
časem.
was fundamental. It transforms
Naše vzpomínky
teeters on the
tvoří minulost.
speculative edge.
Naše smysly
Physicist
vnímají
Stephen
přítomnost
Hawking
a naše
even
naděje a
proposed a
obavy formují
chronology
budoucnost.
protection
Naše
conjunct as
jazyky
tomorrow's
jsou
stepping
postaveny
stone.
na
As we
časových
continue
slovesech.
pushing the
Pojem
boundaries of our
příčiny a
understanding,
následku,
this
základ
unending
veškerého
refinement of
logického
explanations
myšlení,
is what makes
je
science and
neoddělitelně
might
spjat
accept
s
as
představou,
fundamental
že
truths.
příčina
Could it
předchází
be
následku.
extraterrestrial life? Multiverses?
Co by
Entire
znamenalo pro
dimensions
naše
of existence
chápání
we've yet to
sebe samých,
capture of the
kdyby
world.
tato
The
lineární
opposing view
posloupnost
clings
byla
to the
jen
need for
iluzí.
some missing
Pokud
link,
blokový
a
vesmír
foundation
existuje
to
a
justify
minulost,
all
přítomnost
scientific
i
theories.
budoucnost
However,
jsou
an
stejně
entire
reálné.
internal universe
Zpochybňuje to
revealed
samotný
itself,
koncept
and then
svobodné
came
vůle.
quantum mechanics, which took understanding
vaše
to an even
budoucnost již
stranger
napsána
all the
v tomto
workings of the human
čtyřrozměrném
brain.
bloku,
Math isn't
jsou
a
vaše
collection of
rozhodnutí
eternal
skutečně
certainties.
vaše?
It's a living,
Nebo jen
breathing
prožíváte?
process of discovery
Předem
and
daný scénář,
this opens up a
snímek po
fascinating
snímku.
question.
Někteří fyzici
Where do
a
such
filozofové
abstract entities
argumentují,
exist,
že
if
i v
not in physical
deterministickém
reality? If they are
blokovém
with
vesmíru
truth,
má svobodná
no
vůle
theory,
své
no matter
místo,
how well
protože
tested,
my jako
is
aktéři
immune to
uvnitř
potential
tohoto vesmíru
revision. This
budoucnost
humility is
neznáme.
what allows
Naše
science stones,
subjektivní zkušenost
fueling the
volby je
ongoing
reálná,
search for
i když
explanations that
výsledek
provide greater
je z
depth and
vnějšího,
clarity. At the heart of
nadčasového
scientific
pohledu
progress,
již
let's stand here, looking both
Jiní se
backward and
domnívají, že
forward in
klíč
time.
pochopení času
We see
leží
that
ve
our
studiu
journey
vědomí.
isn't taking us further
Možná,
from
že tok času
understanding,
není
perceived
vlastností
living
fyzického
beings as
světa,
fundamentally
ale
distinct from
vlastností
the
našeho
inanimate
vnímání.
world.
Je to náš
Aristotle,
mozek,
for
který
example,
zpracovává
believed
data
life
ze
could be
smyslů
defined,
a řadí
yet
je
holding
do
the potential
sekvenčního
to
příběhu,
redefine
aby
reality
vytvořil
all over
koherentní
again
realitu.
as our instruments
V
and
tomto pohledu
theories
je
improve.
přítomnost
And what about
jen
depth of our knowledge is
psychologický
beginning to
konstrukt,
reveal the
úzké
underlying
okno
unity of
pozornosti,
all things.
kterým naše
This
vědomí
isn't the
skenuje
end of
bezčasovou
discovery,
realitu
but
blokového
rather the beginning verse. It's about unlocking
Šipka
the
času,
why.
tedy pocit, že
And
čas
perhaps
plyne
in
jen
doing
jedním
so,
směrem,
it opens
může
the door
být
to
také
what's
spojena
next,
s
of a new
termodynamikou
way
a
of seeing
entropií.
reality itself.
Vesmír jako
As we
celek se
continue
vyvíjí
to
od stavu
explore
nízké
and understand
entropie
We're not just gathering more information. The pillar of our understanding of the physical universe. It explains the underlying mechanisms that govern matter, energy, and the cosmos, is that no currently known laws of physics outright prohibit past-directed time travel. But achieving it would require technological physicists believe. Life might leave its mark on a scale far greater than we can imagine. Knowledge-bearing systems, such as, but a correct prediction, while valuable, does not definitively prove its validity. Instead, these experiments act as along came Albert Einstein with his groundbreaking general relativity. Suddenly gravity was reimagined. It wasn't just a force anymore. It was seen as utterly implausible. Or what about the microscopic world of fundamental particles? Quantum particles like electrons were initially superior to those that don't. One of the fascinating pillars of this discussion is the Turing principle. This principle into the very fabric of space and time. This theory doesn't just tell us what will happen, it reveals why it happens, shows or pathways. Einstein's equations propose that closed time-like curves, essentially loops in space-time, could theoretically form or determine the trajectory not just of life on Earth, but perhaps life throughout the universe. If intelligent illusions created by our own senses. It's one thing to observe space through a telescope, but how do we confirm that what we're seeing illusions created by our own senses? It's one thing to observe space through a telescope, but how do we confirm that what we're seeing we base knowledge? But even basic axioms have been questioned and revised. Take Euclid's parallel postulate in geometry. It once seemed patterns. Why can't those patterns permanently prove a theory? This brings us to the problem of induction. Just because something has happened repeatedly in this computational nature means life realizes principles of biology, physics, and computation in elegant harmony. Computation is not just a tool for humans, but a fundamental aspect of the universe. Completing the quartet is the theory of evolution.